Hi everyone, welcome back to week 12 of MEM 30031A Operate Computer Aided Design or CAD system. Before we start, as usual, the disclaimer: this online recording is intended for internal teaching within South Metropolitan TAFE Carlisle WA campus only. You may not either directly or through the use of any device or other means copy, download, upload, publish the content unless expressly permitted by South Metropolitan TAFE in writing. So for today lesson, let's have a look our DAP. We are in week 12 and then you have a couple of weeks before your final test. In this week 12, I would like to focus on assignment 2 as our practice and as a tools as well for you to get familiar with HVAC drawing that we normally use in here in Australia. I have some samples here. For example, this is the, the project that we did at Curtin University quite some times ago. This is what the original drawing looks like. Is it's done. It's quite a long time ago, and we refurbish it by changing a couple of things here. So as you can see here, Curtin University has different standard. If I go to paper space, this is quite different to the title block that we have or you use. I ask you to refer to BMW, Building Management and Work, as your standard template, but Curtin has their own templates, which is already uploaded in Dropbox. That template is free from the website, so anyone work with Curtin has to comply with the template. And as I mentioned before, if you work for different company like Public Transport Australia or with Woodside or BHP or other large company, they normally have their own standard that you have to use or a guideline. The next samples, this is a government job similar to Carlisle, but this is not Metropolitan TAFE. This is a 19 Aberdeen Street. Remember last week we were talking about symbol or legend, like say isolation valve using this kind of symbols. This is a control valve, balancing valve, non-return check valve, strainer, and etc. Now there is no hard rules doing this. I've seen many people use slightly different symbol. Um, we've done project for Chevron. They use different symbol again, but the meaning of the symbol is literally the same or more or less similar from one company to another company. That's why having legend here is very important because the symbol of IV, most likely people will recognize this as a valve, but sometimes IV can stand for other thing. In industry, you can have pneumatic valve or is automatic valve or whatever, gate valve or ball valve. They normally quite pedantic with that because it's industrial. In HVAC, we just say isolation valve, and people normally would know anything below 50 mil will has to be ball valve, and above that would be butterfly valve. This is a consultant drawing or an engineering drawing. This drawing is not intended to be as a construction drawing or a shop drawing. Shop drawing means the drawings that are ready for manufacturing. For example, the ductwork and pipework layout for in here. If you look, this is a new work. We're having a new chiller install and new cooling tower. This is the existing equipment that we demolished. So this existing chiller, existing cooling tower that demolished. Now I've drafted this project by myself. I went to site, I measure everything, so this is quite accurate. You can see here there's a distance that I had reference, and then the intended design here I measure it, and I believe it's fit to the site because I measure it. But again, this is a consultant or engineering drawing. The purpose of this drawing is, first, number one, is show the intent of the work has to be done. Number two, this drawing intended for pricing. So if this drawing goes out to the market, multiple mechanical contractors will quote on this project, and by looking this drawing, they will be able to develop a project budget or competitive budget, which they submitted to the government, and government will review it for um, for a while, and then they will award to the competitive um, contractors. But you can't, well, technically you can send this drawing to the manufacturing, but once the contractor is awarded, they will redraw this, or they will take this drawing as a base, and they will try to draw it, they try to rationalize it, and they will send the shop drawing back to us as an engineer for approval. Once we approve, they'll go to manufacturing. As you can see here, it, the layout is very generic. It doesn't say how far this pipe from this pipe, or how far this pipe and this pipe from the wall here. In shop drawing, it will be very detailed, like this is will be 300 mil from the wall or something like that. So depending what your intention in this course is, if you going to work in consultancy or engineering, this is a kind of drawing that you want to produce from AutoCAD. You try to be as detailed as possible, so the drawing is complete and it shows the intention of the engineering layout, intention of the work. It can be priced fairly, so when the tender come out, there is no variation because you have covered everything. But if you work from mechanical contractor, normally you have to go to site, um, make sure everything fit, make sure all the consultant drawing that they propose is actually fit. Now there's a couple of consultants out there I wouldn't name, which is doesn't go to site at all. They're just relying on the paper. So you go on site and then just say, oh well, your gears that you specified doesn't fit. Now if you see here, in the old days, I normally just draw this as a circle and have two outlets. This is a pump, by the way. But nowadays, a lot of people or a lot of manufacturers actually release the CAD model on the website for free to use. So what I'll do, I just grab that CAD file and then put it here, and in the schedule I put the schedule. This is from this manufacturer, this is the model number, so I know exactly the equipment will fit. The same like for cooling tower, you can see it's quite detailed. The same with the chiller, is quite detailed. So this is a CAD file from the supplier. I'm not expecting you to draw this yourself unless you have a free time, of course. So let's get used to it. This is a cooling tower. This is a section of it. So the reason draw it like that, rotate it 90 degree, because this line here will line lined up with this line. Okay, and then this another section G that cut through here. So it's cut through the pump, the chiller. I think the buffer tank is missing here for some reason. I don't know why. But remember, this is a model space. So model space is in almost infinite canvas. Really, you can draw thousands of kilometers away from each other. So you can draw whatever you like. And remember, I asked you to do everything in paper space. So paper space is frame. So it does frame the particular drawing that you want to frame. For example, um, that the plant room drawing is like that. And then even I can insert another viewport, and then I have an insert in here. So it does looks quite very neat. So you can cut. So this is a viewport. If I click that, if I expand my viewport, you can see the other drawings start to appear as well. So on that particular viewport, I just frame this particular drawing. And if I want to have an insert, I can go there, frame it, and move it here. Then you can rotate it. So you can have multiple insert with this, which is very handy. Now another advantage of having all your drawing in paper space, you can see here there's 21 total in drawings. So you don't want to print them one by one. You know how a challenge to print from AutoCAD. You have to Control P, and then you have to pick the paper, and then what you want. You want to print a window, you want to print extend, change the sheet, and everything is quite tedious. So with paper space, you can do right click, select all. After that, right click again, and you can do publish. Now in publish here is all your drawing. You just simply Control A, and then you set the plot setting once. So in this case, I name it PDFA1. Then everything will be based on the plot setting that you already created. It's very handy. In one project, we have probably hundreds of drawings, and even with plotted all, will take 2 hours to print, but we can leave it in the background while we're doing something else, not, click, 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 click 200 times, multiplied by 4 times, and try to print everything. So this is about the productivity. CAD, remember, CAD is not Revit. CAD is very manual. It's designed as a tool to aid you in engineering drawing. Okay. The next one I would like to point out, this is our campus, Dev Kalal. So as you see here, um, I've done the tracing for this particular campus. I think this is all block F because we are replacing the chiller, pumps, and air handling unit. So I have to do exactly what you did, what you are going to do for assignment 2, which is transferring the hand-drawn drawing into AutoCAD drawing. So I know your pain. I'm not just ask you to do something out of the thin air. I've been there, and the reason I ask you to do it because it's a great practice for CAD. It's force you to practice. I know if I give you assignment, you probably wouldn't practice it, but if I make it assignment, you will have to practice because you have to do it because you have to submit it for me, otherwise you can't pass the test or the unit. Now this particular Carlisle tape, as you can see here, this is all the chill water schematic that I've done. There's a valve legend here telling which valve is which. Okay. I'm not going to release this to Dropbox, by the way. This is just an example for you. Um, all the ductwork here has been traced as well. All the ductwork has been traced. Now the reason we trace this ductwork is because first, as I said before, it shows the intended of work. So this is the works that the mechanical contractor has to perform on site so they can price it properly. I said, well, remove coil, remove the coil. If you not trace the drawing, you relying on the old scan, you can't clearly see what's going on. Also, doing retrace the old drawing into CAD will help you with heat load. So I can roughly measure the area of the tool store if it's supposed to be a classroom, and I can put it in the heat load. I can do a heat load calculation. This is a workshop next door. I'm not sure if you've been there. Let's see the room that we normally in. No, that's level 1. This is the one. So there's a computer room. We normally sit here. This computer room 2. It's not served by chill water. It's served by normal DX system. These 2 rooms are not part of AC3 anymore. They've decided to take it out from the chill water because at one point they run class on Saturday. It's no point to run the chiller that capable to run the whole block F just to cool down 2 rooms, which just makes sense. And this is the room in the corner, and there's a stair to go down to the toilet if you remember. So once the drawing's been traced, you can do whatever you like. In here is demolition, so we show the extent of demolition, delete, 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 delete. So this magenta stand for delete, 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 delete. Then the new work will follow up. This is the red line is the existing ductwork, and this blue line here, this is the new ductwork complete with VAV system, new air diffusion, new ductwork. Now you can't really, what you see here is you see from top, the top you seeing the bottom, but you're not seeing it under the ceiling. So what you see here is in the ceiling space, okay? And we don't really show what's happening in ceiling space. It's probably a truss or roof members or whatever in the ceiling space that may be there, but this is an existing drawing that we trace. The construction drawing, the mechanical contractor has to go into ceiling space and make sure this kind of system here will fit. It's not going to hit a roof truss or anything. If they see a roof truss, they will probably make the duct shorter, or they have to shift this, or they make a bend. So that's what the mechanical contractor will do. Okay. So this complete drawing here is contain all the schedules that we want. This is the chiller. When it go out to tender, we do not specify what brand the chiller will be. We only specify we want the capacity rating in kilowatt. We want water cooled, and the mechanical contractor have a choice of the selection. Some equipment like suction diffuser, we specify the brand because we want them. filters. We show the brand as well. Cooling coil, heating coil. Uh, really, is probably only one manufacturer in WA, which is called Wright. So they normally do not shop anywhere else. Air handling unit. We again we do not show the schedule. Sorry, the brand, because they have a choice. Um, this is a BMS lease. We'll talk BMS another time, but we are upgrading the automatic control of HVAC system at Carlisle. So you have to list all the points or the control points. The purpose of this again is for pricing. So the total control point is 100. They normally have a dollar per points. They multiply. So after the schedules, we have a details how we want it. This is the VST mounting cabinet. This is the filter cabinet. This is how the roof cowl is. This is a fire damper and other things. Most majority of these details will be available in the company. So like fire damper here, I do not draw it. I just use the company library. So when you work in company, they will have kind of details that you can use. The VST cabinet, well, this is my handiwork. As you can see here, it's not as good as the fire damper, but it does show the intention how I want the VST cabinet looks like. The same with the filter arrangement here. This is not the standard detail. I have to draw it by myself because um, this has to be measured on site. Um, Transfer grill, diffuser, these generally are pretty standard details that you can pull. That's it generally for tender drawing. This is the information that you have. We have this as a site plan as well, which is an extra, but generally you have a schedule so you can, mechanical contractor can price, details, demolition drawing, new drawing, and the most important thing is legend. So dark work here, just magenta means uninsulated. With this kind of hatch, internal 25 mil, triple hatch 50 mil, single hatch 75. Now I notice some consultant using different hatch, so you just have to be careful which hatch is belong to which. So this hatch is not standardized in our industry. Sometimes the single hatch means 25 mil insulation instead of this kind of hatch. So always read the legend. Also, you notice here my toolbars is different than what you have. So this is our standard company toolbars here. You can see here is custom AutoCAD. Yours is probably more looks like that. So what the drafting manager in our office, they pick and choose which tools that normally being used quite a lot during the drafting, and they make it as a custom on AutoCAD. So that's what we end up. Even then, like this, I probably not only use 20% of it. The rest I'm not really using it quite a lot, but they are quite handy sometimes when you work in unique project. So that is the introduction, the second introduction to HVAC drawing. Now the key of drafting it is number one is you are familiar with HVAC, of course, and to get you familiar, that's why I asked you to do assignment 2, which is actually HVAC drawing. Other resource, I asked you to check out Australian Standard 4254.2 and 4254.1. This is Australian standard that govern the ductwork in Australia. So all the ductwork manufacturing has to comply to this. You can have a look how the duct being constructed, how the duct being supported, but this standard doesn't say how you're going to draw your duct. In nowadays with plasma cutter, you can make the duct any shape you like. The key of manufacturing is to make it standard is less waste as possible, which means use a standard duct. So that's the key of manufacturing. Try to avoid a weird duct if you can, then that will avoid the waste. Another resource is the ERA Technical Book 2013. So if you haven't joined ERA as a student, please do so, join up. So ERA Handbook has these tables with a weird number on it. This is what we call a KV, or friction coefficient number. As you can see here, the bigger the number means the the more pressure drop we will have. Okay, so you can do aspect ratio whatever, 0.75, 0.5 aspect ratio, and radius over width is 0.52. Oops, I found 0.57 here, and this will be multiplied by the airflow. So there is a formula here. So kT loss coefficient multiplied by velocity pressure, you will have a total pressure loss. And velocity pressure is 0.5, or half time density of air times velocity of the airstream. So you can make the formula using Excel spreadsheet, or you can use the um, diagram here and then you find out what your friction loss, or you can use a ductulator. But this picture representation give you a good indicator how you normally draw a duct in general arrangement duct. Okay, so check the ERA handbook out. It's very handy handbook. As I point out last week, I still use mine from 2003. And now it's 2020. Hasn't changed much since then. Okay, just to refresh our assignment, I mentioned how we going to do the assignment in first term. I will just do it again in here so it's got recorded. So this is our assignment. It's 13 pages. I only want you to do 6 of your choice, as long as you give me 6 drawing. So you can do this whichever you like. If you feel like a challenge, you can do this if you want to, okay, or that. I don't have any problem. For example, let's pick this second page. Oops, no. What page is this? Page number 4. What you need to do is you have to print it as a PDF. Print current page. So the aim here is to separate each page to individual page. If you have a good PDF software, you can separate them automatically, but if you don't have a good software, you just need to print it to PDF. You may use Microsoft Print to PDF. I have a PDF Exchange editor here, so I'll just use that. We'll have a similar result. Go to properties. This drawing was scanned. I'm pretty sure it was scanned in A1. That's a standard government protocol, so we're just gonna use A1. Page zoom 54 will say maybe 50. No, it doesn't work. Just leave it to fit to print margin. That will do. So you print, you save it. In this case, I will save it in my desktop, but please do not follow me. Please save it into um, your bunker, on your USB, because we're going to use it again and again. Okay, don't save it in desktop. It will be wiped out by the ID. So now click save. Now this is page 4 as individual. So once we save this page 4 back to AutoCAD, I'm just going to use this file. Go here, type xref. Can you see that? Xref. Type xref. Next to this DWG, there is a down arrow. Attach PDF and find the PDF that you did. Page 4. We'll keep it relative to path, and insertion point, we're just gonna tick it. We're gonna specify it, otherwise it's gonna go 0, 0, 0, 0. Rotation, we'll specify on screen. So click OK. Click here, and that's our drawing. Just make it. So once it's in here, we know we need to rotate this. So rotate, arrow for rotate, rotate, and we have to scale it up. So I'm just gonna scale it to 1000. It's not big enough, but we'll do for now. Now we need to find a certain reference here that we can use as a reference. Don't use this printer hood elevation because its scale is 1/20. We don't want that. We want the scale 1/100. I just saw something here. It's a 1500 there. It's 475 here. Okay, so we got a couple of good one. But as you notice here, this drawing is not straight. Oh, although the border line is straight, but the drawing line is not straight. So what we'll do, we'll try to straighten this drawing as best as we can. So we draw a line following this external wall. Just check the line. And then we also going to draw a straight line now. Select this drawing, type align, A-L, align, top point, go to top point, bottom goes to the bottom, and read the command. Would you like to specify third point or continue? We're going to continue, so press enter. Read again. Would you like to align? Yes or no? If you press no, it will align, but it only aligns the orientation. If you press yes, it will align both orientation and the dimension. At this point, we'll just say no. We just want to make the orientation right. Okay. So vertically it looks straight, horizontally probably not too straight. See that? It's not really straight on horizontal. Now I don't want you to chase your tail to rotate this indefinitely. you rotate vertical or you rotate horizontal. Okay, we try our best. Here it looks like straight vertically, so I'm quite happy with that. I will deal with the horizontal line myself. So now you have the drawing that are orientated 80% correct. What you have to do now is to make the drawing as close as possible to the original scale. For example, here, this is 1150 from here to here. If I took a measurement from this point to this point, it's only 866. So we are short. Okay. Now the best way to do this is select the drawing, press scale, SC for scale, and type 1150 divided by 866. You understand what I'm trying to do? We want 1150 as our reference point, but we only have 866. So 1150 by 866, that's our scale factor. It doesn't always work. You probably have to do it 2-3 times, but let's give this one a go. Don't know what's happened there. 1150 divided by 866. Here you go. Now, let's check that again. 1147. Good enough. Let's check this one. 475. We will have 483. So I think this scale is good enough. Again, I don't want you to chase your tail. If you keep scaling, you will never end up correct. You will keep chasing your tail because this drawing is probably broken during scanning or whatever. Now we know this drawing is quite good now for trace. So if you go to your layer, this layer here is based on BMW. So if you want to replicate that, go to the BMW guideline that I have in Dropbox. Otherwise, if you open the BMW standard drawing, it will contain this kind of layer as well. So we want to draw ductwork, we use 880 duct. Now the best way to draw ductwork is to draw a center line. So you can see here the duct is 375 by 300 to 250 by 300. So this little duct is 250 by 300. This big duct is 375 by 300. So try your best to draw a line from the center of this duct like that. You don't have to finish it, and then maybe from that side. Okay, and then you type F for fillet. Because this is a 90-degree bend or straight bend, sharp bend, you want to have a radius. So go down here to the bottom, radius. You want the radius is 0. So once you happy with the radius 0, connect that and connect that. It will have a straight line. So the duct is 375. Now you write offset, type 375 divide by 2, and you offset this duct. As you can see here, you have two lines, which is 375. Now this 250 by 300, you have no choice, but you just draw the line at the bottom like that. and then you offset it by 250 like this. Then you can join them, join them, join them. You can delete this extra line if you like, and then just use the line at the bottom. So tracing, I want you to trace the architectural based on what you have, because there is no dimension. We can't really do much on this architectural. So for the architectural, you just have to draw a line like that and like that. It's not even straight. Then you offset the line as the best you can. Okay. But for ductwork, because the size is given, I want you to draw it as accurately as possible. The position might differ by, a little bit, 50 mil, but I know the size is correct. And you don't have to put all the numbering here or all the notes here. What I want you to do is just to put the main notes, such as duct size 250 by 300. That important. This size 375 by 300. That's important. The 375 long is not too important from now, because this duct is there, was installed already. The purpose of 2375 long is for the duct manufacturer to know is 2375 long. Okay, this is the manufacturing notes. This one I want you to put as 500 liter per second. So if engineer read your drawing, they understand, okay, so this diffuser has 100 liter per second coming out. The room number I want you to note. Equipment tag VVB11, so variable air volume box number 11, so please write that one down. The notes like this: FOB trans, so flat on bottom, transition. So this transition here is flat on the bottom, means it's transition on the top. You don't have to write this one down. I don't really need it, okay, because it's there, it's installed. But you can write 650 by 300 to 650 by 450. Just write that one down. And I think that's it. You don't have to do these notes. Don't really need the notes. Don't really need the legend. Okay, it's already there. But just bear in mind, dot 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 means 25 external insulation, and without dot 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 is internal insulation. Oops, no, it does have like a little dot here, but you don't have to do this legend. Okay, this is not a new drawing. But you make when you draw a new duct on top of that existing duct, such as that, and you see here, although there is an insulation on this duct, I do not show it because the heads would be clashing with the heads that I want. So triple line here means 50 mil insulation for the new duct, and existing duct I'll just take the insulation off, means not touching it. So that's how you do your assignment 2. Please keep going until you finish. Now there's multiple way to insert PDF into CAD. You can technically drag the PDF into your CAD file instead of doing the file references. What I did find with dragging PDF is sometimes when you change computer, the path is broken, and I have to reinsert and redo all the hard work again, resize, rescale, realign. So that's quite painful. The safest way is to do file reference. So wherever the file reference is, even though you change the computer, you can go save path here, and you can always update your path. Sometimes if sometimes it the drawing will recognize it. Okay, if you keep the XREF file and your CAD file together in your USB, if you change computer, it will automatically recognize the path, so you're not losing your drawing. Okay, that's all from me today. Keep practicing and see you next week.